focused
Recording in
topic.
progress.
The simple linear regression is a regression model that estimate the relations between one dependent variable and another independent variable using a straight line. Both variables should be quantitative. So we can simply say the goal of the simple linear regression is used to predict the value of dependent variable based on the independent variable. So now see, we are having some values in the x-axis and we are having some values in the y-axis. It is assumed that the two variables are linearly related. Hence, we try to find a linear function that predict the response value y as accurately as possible as a function of the future or independent variable x. So this is the technology we are having. So before moving the code, just we see the mathematical background of this technology. Actually, now we are seeing this supervised artificial intelligence in the subset of machine learning is the subset of AI, as well as the deep learning is also a subset of machine learning. From this whole pool, just we are selecting the machine learning. From that machine learning, supervised machine learning. From the supervised machine learning is the first simplest algorithm is the regression method. From this regression method, we are choosing the simple linear regression algorithm, FLR algorithm. So just we see the mathematical background. See, actually, the linear regression, see the simple linear regression is start from the algebra. Actually, what is equation? If you do not know any idea about the maths, please listen this. Actually, what is equation? See, actually equation is the mathematical expression that contain an equal symbol. Equations often contain algebra. Actually, algebra is used in maths when you do not know the exact number in calculation. Actually, algebra is the basic background of the simple linear regression. In this algebra, actually, we are forming the equation. An equation is written as two expressions connected by the equal sign. The expressions on the two sides of the equal signs are called the left-hand side and the right-hand side of the equations. See, now we are having the x plus 2 is the simple equations and equal to 6. Okay, see, if we are applying the value to the x4, then 4 plus 2 is equal to 6, then 6 equal to 6. So this is the simple equation. In this equation, we have to know the some part of the equations. 4x minus 7 is equal to 5. Actually, the 4 is the coefficient and x is the variable, and 7 and 5 is the constant, and minus and equal to are the operator. Actually, a variable, what is mean by the variable? A variable is a symbol for a number. It means the value can be changing during the program execution. So that's why the x is the variable. And always the coefficient is combined with one variable. And this is the simple equation and part of the equations. And we see example ax square plus bx plus c. This is also a simple equations. Here, see x is the variable, a and b are coefficient because a and b are combined with the x variable. So that's why we are calling a and b are coefficient. The c is the constant, and the operator we know the plus and minus equals are the operator. Then we are moving to the expression. So in this, see the expression is a term is either a single number or a variable or numbers and the variables multiplied together is called the expression. We are having the three types of expression. The first one is the monomial expression. The second one is the binomial expression. The third one is the trinomial expressions. In the monomial expressions, we can see 3x y square. This is the single term. Then 5x minus 1 is the 2 term. This is the binomial equations. And the third one is the trinomial equations. It's having the 3 terms. 3x plus 5y square minus 3. So this is the types of equations. And beyond the 3 terms, we call it as the polynomial equations. So these are all the basic items in this equations. So these are all the simple linear equations. Y is equal to 2x plus 1. 5x is equal to 6 plus 3y. So these are all the simple linear equations. And this is the y is equal to mx plus b. It is a straight line to forming the line by using the formula y is equal to mx plus c. Now y is equal to 2x plus 1, it is the equation, and we are applying the value for x. X is the independent variable. So we are applying the -1 for x. So we will get the output as the -1. If we are applying the 0, so y is equal to 2 into 0 plus 1 is equal to 1. So when we are applying the 1, we will get the 3. So likewise, we are writing the code in Python to predict the future value. That's mean the dependent value. These are all some different forms of equations. Y is equal to mx plus b. This is the formula for the straight line. So these are all the simple mathematical background of the linear recursion, simple linear recursion. Now we are moving to the slide. This is the Python program. Executing the spider. So now we are see the recursion. So in the recursion, we are having this much type: simple linear recursion, multiple linear recursion, polynomial linear regression, decision tree, random forest, support vector. So these are all the types of recursion. So linear recursion is the common method to model the relationship between a dependent variable and one or more independent variable. But in the simple linear recursion, we are having the one dependent variable and one independent variable. Actually, the linear models are developed using the parameters which are estimated from the data. Linear recursion is useful in prediction and forecasting, where a predictive model is fit to an observed data set of values to determine the response. So linear recursion models are often fitting using the least square approach, where the goal is to minimize the error. See, we are having the 3 types of correlations. The formula is y is equal to mx plus b, or y is equal to c plus bx. We have 3 types of correlations. One is the positive correlation, and one is the negative correlations, and one is the no correlations. Actually, the straight line may be moving from left to right in an upward, or left to right in a downward, or in a straight line. The line that goes up the right have a positive slope. It's mean going from left to right line with positive slope. So it's called uphill. Suppose in the second diagram, we can see the line that go down to the right. It is called a negative slope. So going from left to right, line with negative slope is called downhill. And the third diagram shows if a line is horizontal, the slope is 0. There is no updation. So this is the constant. Actually, the formula for the best fitting line or the regression line is y is equal to mx plus b. Here we are having the formula y is equal to c plus bx. Just we are applying one value. Actually, we want to convert the Celsius into Fahrenheit. So Fahrenheit is equal to 32. 32 is the C, plus 9 by 5 is the B, and X is the Celsius. See, the X is the input variable. That means the independent variable. We are giving some value Y. The C is the constant value. Okay, and slope, actually B is the slope or the coefficient. See how to find the slope and all. So Actually, the slope of a line in a plan containing the x and y axis is generally represented by the letter m. Actually, we denote the slope called the letter is m, and is defined as the change in the y coordinate divided by the corresponding change in the x coordinate between two different points in the line. In mathematics, the slope of a line is a number that describing the mathematical view, we can describe the line is a number that describe both the direction and the steepness of the line. And it is denoted by the variable m. So here we are having the two data, x data and y data, experience and the salary. So experience in the x-axis, salary in the y-axis. So we are applying this formula. So it is used to find out the slope and the constant. So to find the slope, we know the formula of the Euclidean distance. The mathematical background of this slope to use it to find out the distance between the 2 points is by using the Euclidean distance. The Euclidean distance is nothing but the 2 points. The first C, point y1 minus y2 minus y1 and x2 minus x1. So the first point is considered as x1 y1, then x2 y2. So to find out the distance between the 2 points by using the formula, b is equal to y2 minus y1 divided by x2 minus x1. This is the mathematical background is the Euclidean distance and the Pythagoras theorem. Actually, it is used to find the distance between 2 points. And we can see the constant c, where the line touch with the y is the constant c. So for example, the initial salary is 2000. So the c is the 2000. So this is the mathematical background, the slope and the constant and the best fitter line. So we can find the best fitter line, and this is the formula. So we need not worry about the formula and this type of line, slope. So everything will be already written in a Python library. So our work is to find out the task or our model, then just we listen or see the mathematical background, then write the coding. So now we are going to the step-by-step approach. Before that, just I conclude the regression. Actually, slope is calculated by fitting the ratio of vertical change to the horizontal change between 2 points. That's mean x1, y1, x2, y2. Yeah, line is increasing if it is goes up from left to right. Actually, the slope is positive. If the line is decreasing, if it is goes down from left to right, we can call it as the slope is negative. If the line is horizontal, the slope is 0. So now we are moving to the hands-on, the third part, hands-on training. So the step we can clearly import required library. First in the Python, we can import needed required library for to making that model to predict the y value, especially in the simple linear recursion. The second step of coding, import data set. You may getting the data set from the internet as an Excel file. Then third step is split data as an independent and dependent variable, two types of variable. So X value and Y value, already I can show you that. Then check the missing value. In the data set, some of the fields may be missing. So the impute function is in the Python, that is in the sklearn library. So just we are included the sklearn library, and by using the impute function, we can predict the missing value. This is the optional. The next one is splitting training set and test data set. So training data set. So first import the data set, find out the split the independent X value and Y value, checking the null value. After that, splitting the training data set and the testing data set. Then build the model with the test data and predict using training data. Then by using the, actually this has been done by using sklearn library, and the linear regression model is the function that is available in the sklearn library. So we can build the model. After build the model, visualize the output by using the matplotlib library. So each and every mathematical concept has been imported in the Python library. So our work is just to identify the problem and to select the technology that may be under the category of supervised or unsupervised or the semi-supervised. So find out the technology which we are going to apply. Then just we listen the mathematical concept behind the technology. Then third one is to find out the appropriate library in the Python and include it. So we no need to calculate manually the mathematics and all. So everything has been already done in the Python library. So now it's better to move in the hands-on session. I am using the Anaconda spider is the, in my personal opinion, it is the best tool. You are having the Jupyter and all variety of IDE for explore the data and making the AI code. You may using the JavaScript and Java. These are also used to making the machine learning things, but actually it is the best one is the Python, and the IDE for Python is Spider, Anaconda Spider. The Anaconda the Anaconda is available for two parts, one for enterprise edition and another one for the open source. Actually, the open source is we can use for research and it's like a teaching purpose. So it is the open source. You can download it and install it. The Spider is the very good IDE for making the research and all. So first, see the simple program. Yeah, this is the simple program. So our aim is to implement the simple linear regression. So what is simple linear regression? It's having the X value and it's having the Y value. So X value in the independent, Y value is dependent. The Y value is always depending to the X axis. Then import the model. Then split the data set. Then apply the linear regression model. Then plot, making the graph. So this is the steps already we have seen in the slide. So see in the right middle, remove all variable options is there. If you click this remove all variable, the old things can be erased in the Python IDE. So see, first step, import required library. See. Now I am going to import two library. The first one is matplot library. Second one is sklearn library. Here I can run in the IPython console. See, now the matplot library has been included. Okay, so the first step has been completed. So what is a matplot library? Actually, the matplot library is a collection of functions that is used to make actually we are using the MATLAB. Each plotted function makes some changes to the figure. Just we can create the figure and all, like this graph and all. We use the matplot library in the Python. So first step, we included the library. So second step, we see. Second step, import a data set. Actually, I am hardcode the value, X and Y value. Actually, import the data set. I will show you in the next program. The third step is split data as an independent variable and the dependent variable. So now I included the data set as well as I split the data set into the X-axis and the Y-axis. Now I can run in the IPython console. Now you have this is the list of X value 6, 8, 10, 14, and 18. So I have included. So Y value, see the Y value 7, 9, 13, 17.5, and 18. This is the Y value. So now we can split the dependent and independent variable. In this program, simply we are not doing any missing value calculations. These are all, we are omitting that. So directly we are moving to the splitting and training data set here. This is the sklearn library is used to split the training data set and testing data set. I am going to split the X train, X test, Y train and Y test. Okay, the function is called train underscore test underscore split. So we have to know the sklearn library having the function name is train underscore test underscore split. We are passing 3-4 parameter X value and Y axis value and the test size, how to split the data. Usually we are splitting the data set into the 30% for testing and 70% for training, or 80-20. So that's why I am giving 30% for the test size, the remaining 70% for the training size. So now I am going to execute the same code in the Python console. See, now the function is, so this is the X value, 6, 8, 10, 14, 18. Now we are going to see the X test. X test is the 30%, so only it take 10 and 6 for the testing data. And the X training data is the 70% or 80%. 88, 14 and 18 are the training data set, as well as the Y. So now we import the Y, 7, 9 and all the values of Y. Now we split the Y as the testing and training. So this is the Y test 13 and 7, and the Y train, you can see the 9, 17.5 and 18. That's mean 30 to 70, 30%. So now we split the data set. So the point 6 is over. Now 7th point, we are going to build the model. So actually my model is price model. It's my user defined name. Actually my model, I would like to create the price model. Actually the program is used to find out the price of the dosa with diameter. When the diameter is getting increased, the price of the dosa also getting increased. So I would like to predict the price of the dosa. So I have created my own model, is called the price model. So assigning the linear regression function that is available in the sklearn library, and assigning the linear regression function. Actually, I have shown you all the mathematical things, you know, the y is equal to mx plus c, and line, the fitted line, and the formula you can see. So everything, the best fitted slope, so the formula, and the slope constant. So everything has been, so the correlations, everything has been included in the linear regression function that is available in the sklearn library. So we have to identify the proper library and the corresponding functions for our model to predict the future value in the linear regression. So now I am going to execute my model, price model. Yes, now model is assigned, and assign my data set X and Y value. Actually price model dot fit of X and Y. I would like to assign the X and Y value. Okay, the value has been assigned to my model. So the last thing, see, build the model. Now we have completed the model. This is the matplot library. This is the matplot library that is used to visualize the graph. I would like to run the coding. Now we are getting the graph. See, from this graph, we know the title is whatever. So dosa price prediction is my title. I can give any type of title. And the X label is the diameter, and the Y label as the rupees price, and the plot X and Y, and it is starting with 0 to 25 in the X axis, as well as the Y axis from starting 0 to 25. Now we see from this graph, we can see when the diameter of dosa is 6, the price is 7 rupees. At the same time, the diameter is 10 and we have the price 30. So diameter is 14 and the price is 17.5. Now you can see in the graph. 18, the same as 18 price. So now my work is to predict for example, I would like to predict the price for dosa actually, which is in 21 diameter. So now I execute this function. So I would like to execute in the IPython console. Yes, now see, now we are having the price. When the diameter of dosa is 21, we are having the price 22.46. So this is the simple model that has been implemented in Python for simple linear regression. So almost now we complete all the steps, but except one, checking for missing value. Actually, now we are not implemented this step in this program. So we are moving to the next program. So this is the simple linear regression model. Okay, now we are moving to the another one program. The program will cover all the things. Yes, this is the program. Now we remove all the variables from the IPython console, and this is the variable explorer. You can see the variable plots and the files. What are all the files included here? Everything you can see in this dialog box, plot, variable and all. So now we are moving to the next example. I hope it will cover all the steps of simple linear regression. So first one is we included the pandas. Actually, what is the use of pandas? Actually, pandas is one of the most famous library in Python. Actually, it is used for exploring the data. It's for data analysis in the data frame. It's a labeled array and holding data type. That's mean access label. If you want, just I would like to run. Okay, I have another one program. So we included the pandas library. So I run separately in the IPython console pandas library. Now you see the pandas library has included in my program. The second one, the Numpy. So what is the use of Numpy? Actually, Numpy contains the multi-dimensional array and matrix, and it is used to split the X and Y data and all. So I would like to import the Numpy library as well as the matplot library. Already we have seen the matplot library. It is used for making the graph and visualization and all. So see now pandas library has been included and Numpy library as well as the matplot library. Now we are moving to see the step import dataset. Now the first step is import required library. Actually, I need 3 library, actually 4 library: pandas, Numpy, matplot, and sklearn. So I included the 4 library. Then we are moving to the import dataset. Okay. Now I am using the dataset salary underscore data CSV. It is the CSV file. Now I am going to include the dataset. Now you can see. Okay, now you see that pandas has been included, Numpy, matplot, and my dataset. See, this is my dataset. This is the salary and experience. Okay, I'm having nearly 50 data, 58 data, 58, 59 data. The first column is the experience and the second is the salary. So experience is in Y, and the salary for, sorry, X, and the salary for the Y predicted value. So now we included the data set, then split data set as dependent and independent variable. Now we are going to split the data. Before splitting the data, just we check if there is any null value or the blank field is available. So see, now we are checking for missing value. Before that, just we using the isNull is the function. Data set isNull dot sum. So it is used to give the any null values. So now I am going to separately run these two lines of code. Actually, there is no X years of experience 0, salary is equal to 0. It means there is no null values in the data set. Okay. So now the data set has been splitted into the X and Y axis. Okay. This is the step 3, split data is dependent and independent variable. Step 3. Now we are going to execute the step 3 in the IPython console. Now I am splitting the data X and Y. Now you can see. So this is the X data from the data set. It's for X value, and now you can see the Y value, and it is come from the data set. So you can see all the 59 values from 0 to 58, totally 59 values are there. Okay. Now once again we are going to check any the missing value in the actually there is no missing value, but even we can check it 1 second. Actually we are checking the missing value in the X and yes, no, 0. There is no missing values. So now we are going to the next step. The step is okay. Now we are going to checking the missing value. So the impute function is used to predict the missing value and assign the new value based on the mean median strategy. See, imputation. The imputation function is used to replace the missing value or the null value in the data frame in our data set. So how the impute function, what method the function used to replace the value? If we use the mean, median, and the most frequent value. So using any one of the technique, the impute function is used to replace the null values. I can execute the impute function separately. See, this is the simple program for making the imputation. So you know the import Numpy and sklearn, and see now the imputer is my own variable, and c equal to simple imputer is the missing. It is the function that is used to replace the null values. What the strategy? I am going to specify the mean strategy. The strategy by using this strategy, the simple imputer function is going to replace all the null values. That's mean missing underscore values equal to np is equal to nan is nothing but missing value, not available value. That is the np dot nan, and the using the strategy. Now I am having the data. See 12 np dot nan 34 10 comma 32 comma np dot nan np dot nan comma 11 comma 20. Finally, I am going to print the original data and after imputation. So I would like to remove the previous variable. Just I would like to execute this. So now see, yeah, see in the output area 12 comma nan comma 34 comma. So these are all the null values available. So after making the imputation, see, it will make the alternate mean values 12, 21.5, 34, 10, 32, 27. So see how it is possible. See, you can see actually how the 11 will come here. Actually 12 plus 10 is equal to 22. 22 divided by 2 is equal to 11 because it is the mean. And 21 point, how it will come here? 32 plus 11 is equal to 43 divided by 2. So you will get the 21.5. So as well as the 27. So the impute function is used to fill in the missing value by using the 3 mode or 3 strategy. The first one is the mean strategy, medium strategy, and mode frequently occurrence of values. I hope you got the impute function. So now we are moving to our program. So I would like to explain, see, this is the training and testing. It is a simple program. You may have the training and testing data set. See, as usual, import the NP, that's mean Numpy library, and sklearn library. This is the simple program, how to split the training and testing model. So now I am having the X and Y value. See, already you know these are all the basic Python code. Okay, so now print X and print Y. See, so the data set, Y data set and the X data set. So we can separate the data set here. So here we can see this, the data set. So X train, Y train. So this is the simple function for splitting the training data and testing data. So now we are moving our main program. So remove all the old variables. Now I can run the part of the code in the console. Yes. Okay. Here now we are going to predict the missing value. So as usual, import the simple imputer function from the sklearn imputer library. So see, the simple imputer is the function. Imputer is my own variable. I can give any type of user-defined variable here. So equal to simple imputer is the function. Now we are passing the parameter. Missing value is equal to np.none. It's mean to find the missing value and replace the missing value using the strategy of mean. Now we get X equal to imputer.fit underscore transform. Now the function has been executed. Then finally applying the mean strategy to my values. So I would like to the part of the code in IPython console. Yes. Now you have the imputer function has been executed. So you can see. Now we can see any null values are there. Just we check it out. I execute the single line code np.isLan of x.sum. So it is 0. It means there is no null value in the data set. Okay. And now you know already I told you splitting the X and Y data. So this is our split the training data and the testing data. So now we are going to split X train, X test, Y train, and Y test. So before that, I will show you. This is the data set. This is the complete data set. Then this is the X value. Now we are splitting the X variables, and now you can see the Y variables. These are all the X and Y variables. Now we are going to split the training and test model for both X and Y. So just I would like to run this code in IPython console. See, now we are having the X test. This This is the 70%, 80% of the data belongs to the X test, and the X train. Now you can see that 80% of X train. Hope you got it. Then this is the Y value. See, totally 59 values are there. Now I have split the Y test. Y test 70% and the Y train. Y train is the Y train is the 30%. So now we have split the model. Then see, now we are going to apply our model. Actually, I would like to predict the salary and experience. This is linear regression. Already I told you, linear regression is the function. I am going to include the linear regression. I would like to create the model. Actually, my model is Recursion. You can give any type of name, salary model or experience model, whatever name you want to just use. It is the user-defined one. Now we are going to execute this model creation. So this is the model creation. Yes, now the model is created. Now I am going to fit the X data, X train and Y train to the model. This is the line. See, this is the line. I am going to train the model. Okay, because I would like to predict some of the future values. So that's why I'm going to give the training here. See, so the training has given. How I train my model? By using the X train data set and Y train data set, not a test data set, actually training data set. So I would like to make the model by using the linear regression function. After completion, after creating my model, I would like to train the model. How we are going to train? By using the X train and Y train. Okay. So we predict the Y predict. Now I'm going to draw that. Labels are showing here. Yes, this is the linear regression graph. See, in the x-axis, I am having the experience. In the y-axis, having the salary. Okay. So now I would like to predict if my experience is 12, what will I get the salary? Now this graph shows only the 10, but I would like to predict the salary. My experience is 12. Okay. Yes, now my salary for experience. When my experience is 12, I am getting this much salary. So this is the model. I can run the complete model. First time. Okay, removing all the old variables. Now I am going to run the complete program. Yes, now you can see. Yes. So this is the variable explorer. This is the matplot. You can see the graph and all, and what all the file has been included here. So everything has been shown in the window. Okay, this is the simple linear recursion model. So by using this model, we are going to predict the salary and the future prediction, the price of the market, and the cyclone. Everything has been predicted by using this type of mathematical logic only. The mathematical logic is the basic fundamental thing in all the applications, and that may be artificial intelligence or the supervised learning, whatever it is. So it is the basic mathematical functions we have applied through the Python programming. Now we completed this step-by-step approach. So this is the simple linear regression. So not only the simple linear regression, so all the codings in the Python, we follow this step for very easy. Import the library, dataset, split the data, and check if the null values are there, and split the training and the testing, and build the model. Any type of model, my salary model, experience model, the cyclone model, the market price predict. In this corona time, we are giving to X and Y variable, how many number of patients and the place we are giving, so we can predict the future values. So finally, we are making the model, and we have to train the model by using our data set, because this is the supervised learning. So I already told you, the labeled data. So these are all the labeled data. I mean, I already given some training to the my model. Already I have given the some 70% training. So my model name is Regression. My Regression model is used to find the future value by using the training model. Okay, so this is the label data. But in the unsupervised learning is the another part. Actually, you are not providing any label data. That is the another area. We only focus on the supervised learning. So this is the model. We are giving the training and predict the future value. So hope you know. So if you want, I would like to another one program. So this is the simple program that you can see. It is just for making the plotted graph. And another one thing is the best fitter line. So how to find the best fitter line? So actually, I have shown some formula now. Yes, best fitted slope. Actually, when we are making a straight line, we have to find out the best fitted slope. This is the formula. So this also has been done in the linear regression model. So the linear regression model can take care of this formula, and as well as this slope and the constant and the straight line. Everything has been included in this linear regression model. Just we find out the model to assign to our model which one we want to make a new prediction, and follow the normal procedure, split and find out the missing values and all. So it is the separate program. See, so these are all the 3 lines I would like to execute this program. So manually, I would like to see. So yeah, lots. Now, see, now you are having the different types of actually 4 diagrams here. Okay, 4 diagrams. Yes, 1, 2, 3, 4 diagrams here. So we have to find out the best fitter line. So first, I would like to apply the theta value. This is the same as linear and regression, the same function. I am passing the 2 parameters, theta 0 and theta 1. So I am applying the value theta 0, 1.5 and the theta 1 as 0. The next one is theta is 0 and sorry, theta A is 1.5, theta A1 is 0. The next time theta A is 0, theta A1 is 1.5. So we can passing the different arguments to find the best fitted line. So this is the manually find out the best fitted line. So this is even you need not to manually, because the SLR, the linear regression function will take care of this. So that's all about the simple linear regression in Python. If you want, I would like to conclude the things. So once just I give outline only. So now today we have seen the one AI application. The AI application belongs to the machine learning. From this machine learning, we learned the simple linear regression algorithm. From this regression algorithm, we detailed implement the code of simple linear regression. Okay. So the mathematical background for the simple linear regression is this and that. So what is algebra and the variable, the expressions, and these are all. And another one mathematical background to find out the distance between the 2 points by using the Euclidean distance. This is also included in the linear library. See, now we are going to find the distance between the 2 points by using the Euclidean distance. You know the Euclidean distance and the Manhattan distance. These are all the mathematical terms. And the even the Euclidean distance is based on the Pythagoras theorem. Pythagoras theorem, if you want, just I would like to show the Pythagoras theorem. Okay, so to find out the distance between the 2 points. So these are all the mathematical background in the simple linear regression. So technology, mathematical background, and the coding hands-on. So that's all about it. Thank you for listening my SLR. If you have any queries, please ask.
Thank you for your full explanations. Now, participants, you can have any queries. Now you can ask your query with our guest speaker. He can clarify your doubts in Anaconda software, and if you have any doubts in Spider, you can ask now. Yes, I think Somasundram sir has raised his hand.
Yeah.
Rajkumar
Yes,
sir, kindly unmute. Yeah, you can proceed, sir. Somasundram sir, you can ask your question.
Hello, good morning, sir. Are you able to hear my voice?
Yes, sir. Yes, sir. Please.
Your workshop section is very good.
Thank you.
Easy and simple one. I happy to see your lecturer. Very good manner. Very nice. I don't have any doubt, but how to include the Excel sheets in this data set? We want to read the data set, means we are using the CSV. How can we read the Excel? We want to convert that Excel sheets, or we can use this one itself, this function itself.
No, sir. Just to be included. Actually, we are having the many data set in the net. Sir, the synthetic data or many data sets. So directly, sir, here, sir, you can see now the salary underscore data direct CSV file, sir. You can directly include the file. Though the
Excel file, if I want to use the Excel file, means what is the function? Same read.
Sir, you may use the another format. You can convert it into, sir, like this, the array, the list and all.
Okay.
Sir, here.
Okay. Thank you.
So you can change any type of set into the X and Y. The pandas library will help you, sir.
Okay. Thanks.
Thank you. Sir.
Okay. Very nice. Very thankful to you.
Thank you, sir. Thank you very much, sir.
Thank you, sir. Any other questions? Yes, Subha Manogran sir, you can ask your question now. Host, kindly unmute Subha Manogran sir. Yeah.
Good morning to one and all.
Yes, madam.
Yes,
Yeah.
ma'am, you can proceed, ma'am.
Okay. I have one doubt.
Yes, madam.
Okay, sir. Sir, what's the difference between data mining and machine learning? Is there any differences?
Yes, sir. Yes, madam. Actually, data mining is the technique that is used to retrieving the data from the data warehouse by using the mining technique. Actually, data mining technique, we are using the clustering and all. Actually, machine learning is we are trying to give some training to the machine. The machine can itself predict the future items. Actually, it is both are all different, ma'am. Actually, the data mining, actually the database, if I can say elaborately, the SQL structure query language is used to fetching the data from the database. The data mining techniques are used to fetching the unstructured data from the data warehouse. So we are using the mining technique. So beyond the mining technique, now we are going to train the system by using the Python code by using the supervised and unsupervised learning to find out the same mathematical background, madam. Actually, in the clustering, in the linear regression, everything has been done in the MATLAB also. But in the difference in the Python, we are going to train the machine by using the training data set, using the labeled data and unlabeled data. It is used to find the future value, like the weather forecasting and all. Now we are using this application, AI.
Okay, thank you, sir. Thank you for your clarification, sir.
Thank you, madam.
No, thank you.
Thank you, ma'am. Thank you, ma'am.
Actually, the background is common. We are using the same linear functions in the image processing, and as well as the network, especially the mobile ad hoc network, we are using the same Euclidean distance model. And we can say the Google map, now you are using the Manhattan distance. And we can deeply discuss about the Manhattan distance as well as the Euclidean distance based on the Pythagoras theorem. So the fundamentally same. So that's why I would like to suggest, or I would like to request for the researcher in the beginning stage, you have to learn the fundamental concept of the mathematics. Then you can learn any one of the tool like Python or MATLAB or whatever it is. You can easily update the recent things. Thank you.
Okay, sure, sir. Sure, sir. Thank you, sir. So actually, I'm having one doubt, sir. For implementing this, supervised, simple linear regression algorithm or supervised, unsupervised algorithm. So which software is best, sir? With Anaconda or MATLAB, sir?
Actually, my personal opinion, actually, sorry, sir, I can't get you.
Yeah, which one is easy for deploying?
Actually, Python, Anaconda is the easiest way for.
Okay.
Actually, Python is the easiest way to implement the supervised and unsupervised. Most of the researcher, we can say in our college and the Peria University and some of the institutes in Chennai are using the Python for Anaconda Spider is the best software.
Okay, sir. Sure, sir. Thank you, sir. Okay, sir. Thank
because
you, sir.
you are having the n number of libraries, you can easily include it in the Spider. And the Jupyter also has the same equivalent features of Spider. But my personal opinion, Spider is the best one.
Okay. We can have n number of libraries so
yes,
that
sir.
we can easily extract the libraries. Okay,
the
sir.
one and only work in the Python, just you have to find out the library and the functions.
Libraries. Okay.
If you find the library and appropriate functions, you can easily build the model to predict.
Sure, sir. Okay, sir. Thank you, sir. Thank you, sir. Participants, any other questions? You can raise your hand so that we can unmute you for asking your questions. Kindly raise your hands if you have doubt. Okay, I think participants has no doubts. This, thank you, sir. The session is very informative one. Really, we clearly came to know the concept of testing algorithms in unsupervised learning and types of linear regression model. So we got clear idea about these topics, and also we came to know how to deploy these techniques in artificial intelligence. So once again, thank you, sir, for accepting our invitation, and especially the usage of simple linear regression algorithm for predicting the values with your demonstration. It's really amazing. Thank you once again on behalf of Computer Science Association of Kaamadhenu Arts and Science College, Sathyamangalam, for your valuable presence over here for our today's session, sir. Thank you so much, sir. Thank you, sir.
Thank you, sir.
So as part of the schedule, I would like to call the professor